Okay, good morning.
Morning.
I want to teach you the next section today. That is actually a very important topic, but it's very simple. But before that, if you don't mind, let us solve some A-level questions from the book to refresh your memory a little bit, and then start a new topic under the title of maximum and minimum values, of course, of a function. So before that, let me just, I don't know, the numbers in the hard copy book might be different from what you get. I don't know, I'm just taking it as my hard copy book, because in the electronic version you have more problems, so the numbers are different. But at least I will try to write the question here for you. So this is the question according to the book in my hand. 1322, you shouldn't rely on this number that much. It's a 2-star problem on the level 2 problem, so that's really level 1 question, A-level question. So I want, because might be your book, ordering in your book is different, I would try to write what is in the question. A function is given to you in the form of f of x, ax cubed plus bx squared plus cx plus d. This function, of course, you cannot, the only thing that you know about this function is that it's a third-degree polynomial, because you don't know any of the coefficients, a, b, c, d, are all missing, yes? And then, according to the problem, they tell you that this function, if, these are the information, has a local maximum, am I right? Yes, local maximum at the origin. So I don't know, in the previous exam, many people didn't know about the origin. Origin is just a translation of origo, yes? At the origin, or of course, what do I mean? Means 0 and 0. F, we know that f has a local maximum at the origin, 0 and 0. The graph of f passes through the points -1 and -5 and what? 2 and 4. This is, so one piece of information apparently, this one, and 2 pieces of information here. You are supposed to determine the local minimum points. Determine local minimum, I don't know, point or points. Let us see how this will go. I want you to learn these skills. So if you see how many unknowns you see on the board, A, B, C, D, 4. How many pieces of information you need technically, in principle, not always, but you need how many pieces of information to be able to find 4 unknowns? Yes? 4. So if you have 4 unknowns, in principle, I have to provide you 4 pieces of information, and then I might be able to expect that you can find all of them for me, yes? But how many pieces of information you see here? So for example, the graph of f is supposed to pass through this point. This is 1 piece of information. The graph of f is also supposed to pass through this point. 2nd piece of information. And then, so 2 more I need. Are they both provided for you by the first constraint? Yes?
Well, we have f has a local maximum at the origin, that's another one.
So this becomes 3. So what is about the last one?
I think you have to find out, for example, isn't there a rule that for if the highest degree is 3 or a maximum, 2 maximum or minimum points?
No. Even in that case, that is not a very specified constraint, so that you can use it in practice to find exactly, yes.
For finding the local extreme points, you need to use derivatives, and if you differentiate that function, then you will be left with 3 on those.
Yeah, somehow you're right. So I mean, this f has a local maximum at the origin. If you don't consider this word, then it means that the graph of the function passes through that point as well. So this function passes through this point, this point, this point. These are 3 pieces of information. But this word that I want to force the function not just passes through this point, but also have a max or min point there. Yes, that's another constraint. So in total, I want you to understand, before even starting the problem, there are 4 pieces of information provided for you in this problem. Yes, and then hopefully it is enough. This, I want you to learn these skills, okay? Okay, but now let me start with the first constraint. By the way, this one single sentence gives you 2 equations, not 1. And this will give you the second one, the third one, and the fourth one on the end. So the first thing that I want to use, if this point is supposed to be a local maximum, it should be on the graph. That is clear. When this point is on the graph, it means that its coordinates should satisfy the equation for the function. What does it mean? It means that if I replace x with the x coordinate, what I am supposed to get as the output is according to this again 0. This will give me one of the information, one of the unknowns. How? So 0, so let me write everything. So if you want to read in the future, 0, 0 is a local max. So this on its own gives me 2 constraints. The first thing is f of 0 is 0. Is that understandable for everyone? Why f of 0 should be 0? Because this function is supposed to pass through this. If I ask, of course there are 2 zeros, but this 0 here is the first 0. This 0 there is the second 0. Yes? So the reason that I'm emphasizing, because might be in the exam, they give you 1 and 2. Then you need to understand what to do. What should I write here? Can you tell me? This is one piece of information, but as Casual mentioned, can you yourself say what should I write here?
The k value is also 0.
So what is the meaning of the k value?
The differentiation of that function.
Not exactly.
The value of x in...
No, differentiation is correct. F prime, the k value is supposed to be 0, but I need to calculate it at a number. What that
0?
number? That's also 0 because both of them are 0. Yes? So you see, this is a little bit, I want you to understand that why this is 0, this is 0. If I change this number, for example, let me test your understanding. Instead of 0 and 0, I write 1 and 2. Now tell me what this will be and what this will be. Tell me the first one first. Instead of having f of 0 equals to 0, what should I write if this point were 1 and 2 rather than 0 and 0? Yes, Mr.
f of 1 equals 2.
Yes, is that understandable? This becomes f of 1 equals 2. And now you want to answer, Abdullah, the second one?
f of 1 is equal to 0.
F prime of 1 again equal to 0. Because the k value, this is representing the k value. So I want you to understand, this is a little bit not a very pedagogical example unless you understand what is going on. So if instead of 1, 0 and 0, if I had 1 and 2, then this becomes f of 1 equals to 2. This becomes f prime of 1, but not equals to 2, equals to 0 again, because that should be a horizontal factor. Okay, now everything is clear. But now you see that, can you tell me what is the consequence of f of 0 equals to 0? So let me clean this. It means that when I replace x with 0, this is gone, this is gone, this is gone. What is left is d. What is d? d is f of 0 equals to 0. Okay, so I want to look for a, b, c, and d. I got d. one piece of information, one of the unknowns are actually solved, and I found it. But for using this, don't be in a hurry. How can I use this? I want to calculate f prime at 0. How should I do that? I have to go back and differentiate the function. So for using this, I cannot directly imply 0. I have to calculate f prime of x in general first, which of course is a very, very simple problem for you now. It becomes 3ax squared plus 2bx and plus c, yes? This is the derivative, but now f prime of 0 is supposed to be equal to 0. What does it mean? It means that if I go to f prime, replace x with this number, the answer is supposed to be 0. So if I go here and replace with x equals to 0, this is gone, this is gone. What is left is c is equal to 0. This is the second argument. So you see, usually these two star problems are conceptually harder, not algebraically. You see that is a very simple algebra actually. Okay, now that I know that d and c are 0, it is better to use them before passing to the second stage, because they are very simple numbers. So far, what is f of x for me? C and d are both 0, so get rid of them, and then I will have a simpler function left for me. ax cubed and then plus bx squared. Yes? Okay. Now I think this is even Math 1c problem, because you just need Math 2c, because you need to solve a system of equations. Why is that? How can I use this? Minus 1 and 5, minus 1 and minus 5 is on the graph. Why is it on the graph? Because I myself demand that the graph passes through this. Okay, so what is then? How can I use this? This means that f of what? F of the x coordinate minus 1 is equal to the y coordinate minus 5. Is that understandable for everyone, what I have written? Okay, what does it mean? It means that you go to the function, replace x with minus 1 everywhere, the answer that you are supposed to get is minus 5. Then it means that I replace x with minus 1, do it in your head. Minus 1 to power 3 is negative 1, multiplied here is minus 8. Minus 1 to power 2 is 1 times this is b is equal to minus 5. And you shouldn't expect to be able to solve this, because one equality is one constraint, and then I have two unknowns left. That is why they have to provide you an extra piece of information. And then 2 and 4 is on the graph. This means that f of 2 is 4. It means that if I go to my function, replace x with 2, the answer is supposed to be 4. And then you can do it in your head as well. So you replace x with 2, this becomes 2 to the 3, 8 times 8, and then plus 4b is equal to 4. I prefer to divide by 4 everything, simplify it. So then it becomes 2a plus b is equal to 1. Then you see what is happening. I have a and b unknown to me, but how many equations I have? I have 2, and that's a Math 2c, and the system is so simple that is E-level question in Math 2c, if you want to solve this system. It depends on you how you want to calculate, but I myself prefer to multiply this by minus sign, use addition method. I multiply this by minus 1 and add it here. And we can do it in our head, yes? Minus 1 times minus a is positive a. When I add it here, it becomes 3a. And then I multiply minus 1 by this one, it becomes negative b. When I add it, it is gone. When I multiply minus 1 by this, it becomes positive 5, and I add it here, it becomes 6. And then a becomes 2. And when a becomes 2, I put it in one of these equations and I find b. If a is 2, it becomes negative 2. I move it here, it becomes positive 2, so b becomes negative 3. So you see, I was able to exploit all the pieces. You see, the algebra is just from here to here, and very, very simple algebra. But based on the experience, I also agree that you have to put the stars here, because I don't know, for some reason, people get confused doing these things. Okay, now this is of course not wanted, what is wanted is determine the local minimum points, if there are any, of course. And if there are more than one, you have to find all of them. Okay, then what I have to do? Eventually, I was able to find my function. Do you agree? Because now the function was this at the final stage, but now a and b are clear. So therefore, my function is what? My function is f of x equals to 2x cubed minus 3x squared. That is my function. Now, you can forget about everything that you have done so far. You can consider this function, and this becomes an E-level question, because a function is given, a very simple function, you are supposed to find the local minimum of that function. Yes? And then it means that up to this point, you have only learned one tool, and that is the first derivative test. Later, we will also learn the second derivative test. For this case, it would be easier. But for the time being, this problem is in that part, so let us just use that trick. So, what is that one? So what should I do? Do you remember? I have to differentiate it equal to differentiated. The function becomes 6x squared, this function that I got here. Yes, and then again minus 6x. Very simple one. I put it equal to 0. And then it means that 6x squared minus 6x is equal to 0. You can of course use PQ formula, but this is very easy to factor 6x out. Then it becomes x minus 1 equals to 0. And I hope that you were able to guess you will get 0, one of the roots. Yes? Because this solution will give you candidates for extreme points, regardless if they are max or mean. And we already know that 0 is the x-coordinate of a local max. So definitely, if you are actually exactly know what is going on, you should anticipate. You should be able to anticipate that this x equals to 0 will pop up. Yes? So x becomes 0 and x becomes 1. Okay, then what you do, you can just draw that sign table. X, y prime. Okay, let me write f prime here. It doesn't matter, of course. F prime of x, f of x. And then these numbers 0 and 1, of course you know that the derivative will be 0 here. If I put 0 for x, then y becomes 0. If I put y, don't get confused. This is the f line. I have to go and put 1 here. So this becomes 2 minus 3 is minus 1. Yes? If I choose a number smaller than 0 and put it into the derivative, the derivative is this part. You can imagine that I factor. If I put a number less than 0, this becomes negative, this becomes negative, the product becomes positive. And any number between 0 and 1 becomes negative. After 1 it becomes positive. This is going up, down, and up. As a problem mentioned, you see this point is a really local maximum point, and then that is left for us, and that is the mean point. Yes? So the answer to this problem is actually 1 and minus 1 is the only local minimum point. Is that, yes?
Well, could you remind me how you got to the conclusion of it going up and down?
Wherever the derivative is positive, it is increasing.
It's 0.
No, derivative is 0 here.
Yeah.
This means that less than 0. This means between 0 and 1.
Yeah.
This means larger than 1. So if I put a number less than 0 into my derivative, you get a negative number. You can test. For example, you choose minus 1, put it here, this becomes 6 plus 6, which is positive, 12. So it is positive. And if you choose a random number between 0 and 1, for example, 1/2, if you put it here, calculate, it becomes negative. And that's it. And wherever this is positive, it goes up. Wherever this is negative, it goes down. Yes? Is that clear? Okay. And there are 2 more. I want you to think about them. I don't know how many of you are following my recommendations, but I don't want to solve all of them myself. I want you to leave some problems for you to solve. Next, the problem coming after that is also probably interesting. So try to do that, then probably we can discuss one of them next time. But now let us go to the title of this lesson today, maximum and minimum of functions. Okay, you might ask yourself, okay, we already know about maximum and minimum, but I want to emphasize, if you run a business, you want to, and I say that you want to maximize your profit, you don't care about locally maximizing your profit. Probably you want to maximize it in the real sense of the word. Maximize it larger than any possible number that is possible for you, yes? Maximum is, for us, usually in physics, science, when we want to extremize a function, maximize it or minimize it, we are thinking about the largest possible value, not locally largest possible value, yes? For example, if I have this function, for example, this point is a local maximum, but it is clear that this one, if it terminates here, then this would be your maximum, yes? And this would be your minimum, even though this one is also a local minimum, yes? So their highest point is, we can equip it with this adjective global to compare it with local, or we can call it absolute maximum. It means that larger than all possible values, absolutely larger than all possible values, not just locally higher than the other points. Yes? So these are the adjectives that you might see, but I can just phrase it maximum and minimum. By the way, if I ask you what is the maximum of this function, probably if you didn't know about the local extreme and maximum, this is the natural point to show. Because when I ask you what is the highest, probably you show that one. And if I ask you what is the minimum of this function, you will show this one. Yes? But we also learned local maximum and minimum points were good anchors for put the graph on it, to be able to draw the graph. Yes? But for practical reasons, in science, engineering, any practical purposes, probably we're interested in absolute maximums and minimums. Yes? Okay. This is something I want you to understand, because otherwise you will mix it up all the time. There would be, I told you, this chapter includes a lot of algorithms which are very similar together. If you don't understand what's going on, then you will mix them up. And none of them are in the formula sheet, yes? So you need to know them. So, if I ask you, by the way, let us try to understand it first geometrically. Where is this mark? Oh, it's here. So, if I give you this scenario, so let us just consider the parabola. There is a famous one here. Y equals to x squared. I intentionally put these arrows. It means that they will continue forever. So if I ask you, what is the maximum of this function? What's the answer? Just rely on your intuition and say something. Yes? Yes.
If it goes to infinity, then it's infinite.
Okay, infinite is not a number. So when I say what's the maximum, what do you say?
There is no.
There is no x. There is no maximum. And that's the correct answer. There is no maximum for this function. Yes, there is no threshold that this function can reach that threshold but cannot pass. Yes? Whatever threshold you fix for this function will go beyond. No matter how high you put this expectation, yes? It will exceed that. But so there is no maximum. But what is the minimum? Yes?
0, 0?
No. Minimum, by the way, I told you when I say minimum and minimum point, they are different. So let me just, even for local extreme points. When I say minimum point, then you need to tell me both x and y. When I say minimum, you just need to tell me, you have to tell me the y value. And if I ask you where the minimum and maximum occurs, then it means that I am interested in the x value.
Then it's 0.
So that's 0. The minimum of this function is 0. Right? Is that understandable? But let us, by the way, I don't know, for example, I don't know, this is probably not a real model. Assume that this x is the total number of your production for something, and for some reason you are actually a very good businessman, so the profit is that number is squared for some reason. If you manufacture 1 you get 1 crown, but if you manufacture 2, you get 4 crowns. If you manufacture 3, you get 9 crowns profit, okay? But usually, this is not a realistic function. Because in reality, we have some limitations. In this function, what is the domain of this function? In mathematics, in the realm of mathematics, the domain is infinite, from minus infinity to infinity. You can imagine any inputs. In this answer, for example, you can see that you need to get rid of the negative part for x. Because x was the total number of your production, so there is no meaning to talk about negative values for x. But still, this is not realistic. Because if this is realistic, it means that you have the capacity of producing infinitely number of items. Yes? So in principle, this is not possible. For example, this is the number of manufacturers that you made in a day or in a year. There should be a limit for that. Yes? So this means that usually these functions are mathematically sound, but when it comes to the reality, you need to terminate it somewhere. So you can say that this is a better model. For example, I don't know, 1,000 per day. This is the maximum. And then you get 1 million crowns for that day. It's a lucky day, yes? But then this is a more realistic. Now if I ask you, in this picture, what is the maximum of that? Be careful. The rule of the function is still the same, but the function is not the same. Because you see the difference between the graph of this and the graph of the previous one. The functions are different. The rules are the same. Now if I ask you, what is the minimum of this function you see here? What is the minimum? 0. If you are lazy, not produce anything, you get nothing. Yes, it's still 0. But what is the maximum profit that you get? Yes, Aaron?
1 million.
1 million. So you put 1,000 in x squared, you get 1 million. Yes? So this is more realistic. And now let me tell you another thing. There is some difference. You see, I intentionally put a filled dot here. And if I want to be careful here, I have to put a filled dot here as well. By putting a filled dot, I am emphasizing that I want to include the final point into the function itself. I can also choose to put a hollow. Let me make it clear for you. For example, I start from this one. It means that I am excluding this. So let me put this one filled. And then let us make it very simple. Just a line, straight line, up to some point. And this time I put a hollow circle here. And then below that, for example, I would say this is 10. And then I will tell you that this is, for example, 20. For example, this is a function. And I ask you, what is the minimum of this function? Yes?
0.
0. But what is the maximum of this function? Yes?
Less than 10.
No. So what? Repeat it again.
Less than 10.
Less than 10. Okay. This is not a good answer. How much less than 10? Because I want to give me a number. For that I want you to understand this point exactly. When I ask you what is the maximum of this function, first of all you said less than 10. This is one mistake. You should say less than. If you want to say something like that,
100.
10 is not a good number. What is that?
100.
20. You should at least say less than 20, which is also wrong, but it is better than the previous one. Okay, but what is the maximum of this function? 20 is not the correct answer. Yes?
Would it be like a number that's infinitely close to 10 or something? Like that's really, really close.
Okay, what is that number?
Couldn't we find it through a limit probably?
No.
I don't know, it would be a 9.9999.
Oh, how many nines?
Many.
So if you put infinitely many, that's not practical. By the way, it can be proven that 9 with infinitely nines, with this bar it means that it continues forever, this is exactly equal to 10. Yes? So if you put it 9, infinitely many times, we cannot do that. That I want you to understand something. So you are right. You say that, can I say this point is the maximum point? No. It's clear not. Why? Because I can imagine this point. It's still higher. Yes? Can this one is the be the maximum? No, because I can go, and this I can go higher. Is this point a maximum? No, because I can go beyond that by making it higher. And this will not end. Yes, I can get closer and closer to 20, but 20 is not the maximum. What is the meaning of being the maximum? It means that you find a number so that when you plug it into the function, it gives you exactly 20, and then you cannot go beyond that. That is the meaning of being maximum. Maximum should be attainable. So there is the notion of maximum, and there is another word probably in mathematics, and that's called an upper bound. Yes. Okay, so I can say 20 is an upper bound for the values of this function. It means that all the values of this function are definitely less than 20. But this doesn't mean 20 is the maximum. Because when I say maximum, it means that it should be attainable. It should be achievable. Yes? So, but I hope that you agree with me, no number will give me the maximum. Because first of all, I cannot stand on 10, because 10 is not included in the domain of the function by this hollow circle. That is the message of this hollow circle. Then you might say that, okay, let us be a little bit smaller than 10. Even if you are standing at 9.9, this is not still, you have better candidate. You can make it 9.99. If you say, no, this one is the case, I can make it even better. You see, there is no number that I can tell you the value of this function reaches to its maximum if you take that number. That I want you to understand. So in this case, again, the function does not have any maximum. Is that clear? So if I do this, so I want you to understand the message of the hollow and filled dots in this context. Yes? So the minimum value is 0, the maximum value does not exist. Okay, now this I want you to understand the geometry, and then I can set up the algorithm. You can always follow the algorithm, but the reason, if you don't understand, it might happen that you forget and you cannot be able to retrieve the algorithm. Okay, so do you think? So let us concentrate for the time being on intervals. Just let me consider this A and this B. And on this interval, I have one limited domain for my function, and I have a continuous function. Okay? So let me just draw a continuous function here. Let me start with the field dot. And then I go up and down, I don't know, up and down, and then I go here. Let me make it very clear that I am going higher. So because I want to motivate you to understand it yourself. So what I have done, I have started at some point on A, including this point by field dot and this one. Now, if I ask you if I want to find the maximum of this function, where should I look for? Where is that point here on this graph? So this function is y equals to f of x. So if I ask you, show me by your finger somewhere or say something that I know what is the maximum. Yes?
Are you trying to find a local maximum or?
No, maximum. You shouldn't doubt about it. If I mean local maximum, that's up to me. I have to mention the adjective. Yes? When I say maximum, I mean maximum in the usual sense. Yes?
Isn't the maximum f of b?
F of b, exactly. So in principle, if you want to show something, you say from here to here, I measure, this is the highest value for y for this function, but on this interval. Yes? Is that understandable? So, what is the minimum of this function? What is the minimum? Is this the minimum?
No.
No. What is the best minimum? Probably, what is the only minimum? This one. Yes, something like this. This is your minimum. Yes? But now let us see. This maximum occurs at end point. Yes? this minimum occurs in a local minimum point. Yes? I want you to understand this. Try to imagine. You start with a filled dot, you end up with a filled dot, this is the constraint, and then you are not allowed to lift your pen raise your pen from the board. So then you have to draw continuously. And try to imagine about where the maximum and minimums can occur. Where they can occur. Imagine. Yes?
Either in the beginning or in the middle.
No, repeat it again.
Either it can occur in the middle, where you did there, or at the beginning or at the end.
Yes, exactly. So it can occur at the endpoints or in the middle. That's clear. Yes?
Okay.
If it occurs in the middle, it has also another name. What is that? Local. Yes? So you see, if you have a continuous curve, the max and means, of course you can imagine other graphs up and down in a different way. The extreme points, max and means, can occur into two categories of points. Either the end points or local extreme points in the middle. Is that understandable? So if you want to increase your function and decrease your function, the maximum height can either occur at the endpoints or in the middle, but if it occurs in the middle, it is also of the local type. Is that understandable or not? This is important to understand. Yes? Is that clear? Okay, now can you cook up a recipe for me? If I give you a function which is continuous, I want you to tell me, because I want you to cook up the recipe yourself. If you can't, I will try to guide you, because if you can do it right now, you can do it later. Assume that I give you an interval, and I give you a function. Be careful. It's a very primary school task if I give you the graph and ask you for the function maximum. You can see where is the highest, where is the lowest. That's easy. But the point is that A and B are numbers given to you, and F is a rule. Might be complicated. And now I am asking you, without having the graph of the function, what is your algorithm to determine the max and mean for that function? That one that I mentioned is extremely helpful. We realize max and mean can occur in two different categories. Either they occur at the endpoints or in the middle. But if they occur in the middle, they are also of local nature. This is completely intuitively clear from the picture. If you want to prove it rigorously, that is beyond the scope of high school. But that is extremely intuitive. Now, using this intuitive picture, I want to give me a step-by-step algorithm that when I follow your algorithm, I end up with the max and mean of that function for sure. Just think a little bit. Because this chapter is of this nature. It's full of algorithms. If you want to memorize them, it will not work because some of them are very close in nature together. So you shouldn't mess up. You shouldn't get confused. Okay, so I'm still waiting for you to understand your recipe, to follow your algorithm. Let me ask you, guide you. Where do you look for? I give you number, I give you this interval, and I give you a rule. Assume it's complicated, a function. Where do you look for finding maximum and minimum? Yes?
You either look at f of b or f of b minus f of a.
No, I don't understand what the first one was more or less close to reality, but I didn't understand it.
And then the other one is just the middle, f of b minus f of a, somewhere.
No, somewhere is not an algorithm, yes? Okay, you cannot say to come to the computer, look somewhere. Yeah, you need to be very precise. Yes, Robert?
You could calculate f of a and f of b first, and then you can calculate the local maximums and minimums. So where the slope is 0, and those points, and then you can compare them to see which one would be the
So that was completely natural. Yes? So you see, I told you, first, this needs a little bit of intuition, but not hard one. I try to convince you that if maximum and minimum occurs for a function, there are two possibilities for you to look for. You don't need to, how many numbers are between a and b? There are infinitely many, but do I need to be concerned about all of them? No. Only the endpoints, 2 points, and the points that I might have local extreme points, which we already know how to do them. Yes? So it means that the algorithm, so be careful. This lesson is different from the previous lesson, but it is very close to the nature of it. You might get confused. How should I understand the difference? In exam, if I want to ask you this question, I have to give you the function, I have to give you the interval as well. Look back, in the previous function, in the previous problems, I gave you a function and I asked you to find local extreme points. I didn't give you any interval. But here, I give you a function, I give you an interval, and I ask you for extreme points, not local extreme points. But of course, you yourself find the local extreme points because you understand that is also one possibility, but not the whole story. Yes? So what I tell you, you will do this. Let me write the title and then we follow some examples and we are done. So to determine, so let me write it in this way. Let me formalize it. I don't want to memorize it, but of course, even if you memorize it and use it, that's okay. But I want you to understand it. So, determining determining maximum and minimum I don't want, but if you want, I can write values. But whenever I talk about max and min, I always mean values and I always mean the y value. Yes, determining maximum and minimum values of a continuous function on the interval So this is extremely important, it should be continuous. And that is also extremely important, the sign should be like this, not like that, for example. Because, do you remember, if I exclude the endpoint, I might be in trouble. Or if I exclude the initial point. Why do you remember that example? Here, do you remember, I excluded the final point.
Mm-hmm.
And what was the maximum?
No.
Nothing. So it means that be careful. If this recipe is going to work, it is extremely important to have including part. If I exclude the endpoints, it might happen that the function doesn't have a max or min or both. Emphasize on that somehow in your notes. Okay, the first one is, I would say that determine f prime of x. 2, solve f prime of x equals, determine f prime of x, solve f prime of x equals to 0. Be careful, we don't need to do any sign table here. Number 3, calculate f for the numbers that you get in the second step but I was a little bit careless here. Solve f prime of x equals to 0 and because when you solve this one, you might get some numbers which are not in this interval. I don't care because I just concentrate on that interval. Solve f prime of x equals to 0 and choose, I don't know. And accept only the numbers included in the interval. A, B, yes, something like that. So I mean that you determine f prime, you put it equal to 0 and solve it. You get a bunch of numbers probably. But some of the numbers might happen that they are outside the interval of interest, so just ignore them. We don't care what happens after that. Then take the ones that is in that interval, go to the third step, calculate the values of f for those numbers, you get in the second step. Number 4, calculate f of A and f of B, as Robert mentioned. Number 5, maximum of f is equal to the maximum value found in steps 3 and 4, and the mean of f, the minimum value found in steps 2 and 3. Sorry, step 3 and 4. Yeah, I don't know, because I could probably write it more properly, but hopefully you understand what I mean. If you don't mind, let me emphasize that here, because if you see this sentence in the exam, it means that you have to change your strategy. Instead of going to the sign table and going to draw the table or something, you really don't need to do any table here. You have to follow this, and then hopefully you don't confuse, because there are something in common between this method and the previous one. And that is taking the derivative and equate it to 0. But you don't need to determine the sign of the derivative at all. You just need to do it. Okay, I think this becomes very, very simple if I tell you some examples, and then we are done. So let me just emphasize again. Example. Determine the maximum and minimum. By the way, you see that I am emphasizing the article the. Determine the maximum, because the maximum and minimum, if they exist, they are unique. But not, it might happen that they occur in two different places. Yes, you see, I can have this scenario. For example, if this is 1 unit, this is also 1 unit. What is the maximum of this function? It is 1. I can say the maximum, not a maximum. But this might occur here at 1, this might occur here as 2 as well. So it might happen still at different places, but I cannot say I have a maximum. There is nothing meaning the maximum should be said. So determine the maximum and minimum values of the given function on the given interval. So again, let me emphasize here. So this is the key word in the exam problem. So let me write an example here for you. So number 1, f of x is equal to x to the 2 minus 5x plus 3, the interval is 3 less than or equal to x less than or equal to 6. So let me remind you again, don't get confused. What type of function is this? It's a quadratic function, so it's a parabola. What type of parabola, opening up or down?
Open.
Opening up, yes? Because this one is positive. You might say that, okay, in parabola I cannot have a maximum. You are right. But still, this is asking for it. Why? Because we are not looking at on the whole interval. We are not looking at the whole parabola. We are only limiting ourselves for the values of x which lies between 3 and 4. So it means that I have to cut that parabola at some point. Then I will have something which definitely has a maximum and a minimum. So be careful about it, and that is the indication. Okay, but I will follow the recipe. So if you don't mind, let me just number them according to that. You really don't need to follow these steps according to numbers, but you need to follow these steps. But I want to, from a pedagogical point of view, I just want to tell you that, okay, number 1, I am doing that. So what I have to do, determine the derivative. I don't want to memorize that. Visualize the picture and try to conclude what Robert did yourself. So f prime of x is what? 2x minus 5. Number 2, put it equal to 0. Then what happens? 2x minus 5 is equal to 0. What do you get? You get x is equal to 5 over 2. Should I accept it or ignore it? This is crucial. You need to look here. Is this within this interval? Yes. So it is acceptable. No. So by the way, no, it's not in the interval. That's a good example. Not acceptable. You see, we didn't have this scenario in the previous problem. Yes? Not acceptable since it is not in the interval. Okay? So we left empty-handed here. So number 3. Calculate f for the numbers you get in the previous step. So nothing here. We cannot do anything because we didn't get anything. Yes, so we jump to number 4. Yes? Calculate f of a and f of b. What is f of a? F of a is f of 3 in this problem. I put 3 here. It's 3 squared minus 5 times 3 plus 3. So the answer is 9, 12 minus 3. Yes? And then I have to calculate f of b, which is f of 6. 6 to the power of 2, 5 times 6 plus 3. So 39, it is 9. And finally, the answer. Maximum of f. What is maximum of f? I need to compare the numbers that I got in step 4 and 3. Step 3 is empty, so that is the only numbers that I need to look for. Which one is the largest one? 9. Which one is the lowest one? Minus 3. So the maximum is 9. The minimum is minus 3. Yes? And now they might ask you where maximum occurs, because by the way, of course you are also interested. So you see, let me just tell you something. It's not completely according to the problem, but you understand it better. So if you want to make a profit, maximize your profit, of course you are very interested to see how much you can gain, but that is not an important question. What is the most important question? Of course you want to see what is the maximum profit that you can make by this business. This is motivating, but this is not probably the most important question. What is that?
The x value, how much you have to produce.
Okay, how should I reach to that maximum value is sometimes practically more important. Yes? Yeah, that is important. So for example, if you are a sprinter, might be by some formulas, So might be something. So in ski is probably more tangible. You have seen that probably in skiing. I don't know, the first person and the person on number 20, they differ just by 1 second. Yes? Yeah, I don't know, have you recognized that so much or not? So this 1 second, okay. So it means that might be in the lab or experiment, they say that, okay, from physical point of view, if this is not a skier and that's just a ball or something, I shoot this ball, what is the maximum speed that this skier can achieve? Okay? But that is on paper, according to a ball, you know, shooting, yes? But then you say that, okay, so it means that, for example, so let us say, for example, 40 kilometers per hour, you can see on paper that this is the maximum value that a skier can reach to. But this is the important point is for the coach is to do something that person reaches to this maximum ability. So that is important. So I mean that even though max and mean are good for us, but what is more important practically is when we can achieve, how we can achieve these numbers. Okay? So this is sometimes they can ask you where this maximum occurs. This maximum occurs when x is 6. And this minimum occurs when x is 3. Yes, is that clear? Okay, so I just want you to understand. Okay, now let me extend. I want to keep the same problem, but let me change the interval. Do you think that I will affect the result if I change the interval, keeping the function the same?
Yes.
Yes, it might happen that I am changing the result because I am looking at a different portion of that graph. Yes? So just clear that this might happen, that this is different. So let me give you the same function, function 2 f of x equals to x squared minus 5x plus 3. But this time let me change the interval to 0 and 3. Okay? You see, I have kept the function the same. I want to understand the roles of different factors here. I have changed this interval to that interval. So because that's very similar to this problem, let me just do it fast. So 1, I take the derivative, and this time, if you don't mind, let me just ignore numbering. So you derivative this, differentiate this, it becomes 2x minus 5. You put it equal to 0, and then this gives you 2x minus 5 equals to 0. It means that x is equal to 5 over 2. Is it acceptable this time?
Yes.
Yes. So you just put it in a box. And then what you have to do, you have to calculate the value of the function for the acceptable numbers that you got in the previous step. So I have to put 5 over 2 here. It becomes 25 over 4 minus 25 over 2 and then plus 3. So if I take the common denominator to 4, 24, 5 and then minus 50 plus 12. It's minus 13 over 4. Yeah, please watch my calculations, thank you. Minus 25, it's minus 13, yes. Okay, and now, in what should I calculate? I have to calculate f of the endpoints. So, f of 0, which becomes 3, very simple. F of 3, it becomes 3 to the power 2 minus 5 times 3 plus 3. So it is 12. What is the number? 9. It's minus 3. So what are the numbers significant for us? Are these final numbers. We have to compare them. So you see, there is no track of sign table. Don't get confused. Sign table only gives you local extreme points. It might happen that the local ones are also absolute ones, but that is a different algorithm. Okay, that is a So now if I ask you what is the answer, which one is the highest value? Of course, the positive one is the highest one. I don't need to calculate something. So max of f in this case is what? Is 3. And you see max of f was 9 before. So it was effective. Now min, which one is min? This is around, this is minus 3. Minus 3 divided by 4 is a little bit on the left. Yes? So which one is a smaller? Minus 13 over 4. So the minimum is minus 13 over 4. You see? This is the answer. Yes? So I want you to understand, because there will be algorithms coming in, you have to expect for that. And now, we have a little bit of time. So I want you to think about this. First of all, having a maximum and minimum, is it guaranteed? Just think intuitively. Because if you want to prove it rigorously, it would be beyond the scope of high school. So do you think, so what are the constraints that I need to respect somehow to guarantee that the function has an answer, a maximum and a minimum? I'm just capsulating them because we have already talked about them. Yes, Rocco?
Can't be horizontal, the line.
No, by the way, that's a good question. What happens for a horizontal line? This y is 2. For example, this point is 2. If I ask you, this is a constant function, f of x equals to 2. What is the maximum? What is the maximum? 2. What is the minimum? 2. This function, its maximum is 2, its minimum 2. Yes? But in how many points the maximum is achieved? Infinitely, at all points. In how many points the minimum is achieved? So that is not the answer. So what is the answer? Yes?
Let's say you have money and don't work at all. Then you don't have a company to achieve like this maximum. So x equals to 2.
Okay, so in one case that I have to be careful about is about the endpoints, if they are excluded. If they are excluded, might be I am losing max, I am losing min, or I am losing both. For example, if I give you this, what is the maximum of this function?
No.
Nothing. What is the minimum?
No.
Nothing. So might be I lose both of them. Yes? So one important thing is including these two endpoints. Of course, it might happen that I'm not losing anything. By the way, this doesn't mean, don't get it wrong. So for example, let me just do it like this. I am losing both of these points, but do I lose maximum point? No, because still I have a maximum point. Do I lose minimum? No. So this is not necessarily the case. If I take it out, then you lose max or min. No, it might happen that still you have max and min. Yes? So be careful. One thing is here. Another thing is also important. So, by the way, the intervals that are including these, there is a name for it, so sometime I use it. It's called a closed interval. So when I don't know if this terminology is in your book, I usually don't see that. So when I say closed interval, I mean that I am including both endpoints. Or at least in this session we can use this. So one thing is important. Closedness of your interval matters. Yes? At least it is necessary to think about it. Another one is also important. Another feature. Another feature of the function. This was from the interval point of view. Now, this is also important to satisfy some property. To guarantee that a max and min actually exists. What is that? So for example, let me draw a graph for you here, if I can imagine it myself. So let us do like this. I want to keep the interval closed. So let me so I don't know why I did this. Let me do it better. Don't get confused. So I start from here. and then I start from here. By the way, let me talk about this one as well. So A, and we have here B, and this point is C. By the way, let me tell you, if this is L, and this is M, and this graph is the graph of the function f of x. First of all, if I ask you f of c, what do you write instead of question mark in this picture? Do you write L or M? Because f of c means that you need to find c, okay, c is here. I need to go vertically up, so, and then intersect the graph. Wherever I intersect the graph, I need to read the y coordinate. Yes, Aaron?
I think it's N.
It's M, not L, because I will go and intersect here. So this is the value. Okay, now let me ask you about this. These things you don't see in the book, but this is not hard to understand. What is the minimum of this function and what is the maximum of this function? Minimum is
B.
not B, occurs at B. Minimum is f of B. Yes? This is what is the maximum? Is M or f of c. Yes? So here you see I have a function which is not continuous, but still it contains max and min. Yes? But now can you imagine a function which is not continuous, but the interval is closed and the function doesn't have maximum or minimum or neither of them? Is the question clear? So I want to keep the interval still closed. So assume that you have this interval from A to B. I want to include them because I want to understand the effect of each one of them. So I want to keep the interval closed. Yes? But I want to lose the continuity. Can you draw a graph in the closed interval so that it doesn't have any maximum or a minimum or none of them? Yes?
X equals A.
No, x equals a is not a graph. So you need to draw some graph. I want you to imagine something, yes?
Was it not continuous?
Yeah, so I want you to see the role of continuity in this picture. You already learned the role of the closeness, that it needs to play a role. But now I want you to see the role of the continuity. For example, let me do it like that. I will take it up to here. Yes. And then, yeah, something like this. I will fill up this gap, and then I will go up to here. So consider these two branches in total. For example, let me give this point. I want to ask you if these two pieces together forms my function. What is the minimum of this function? Is there any minimum for this function?
Yes.
Yes. Where is it? It occurs at
F of
C.
C.
But what is the maximum of this function? What is the maximum? Yes?
There is no maximum.
There is no maximum. So you see, because where is the maximum? I hope that you agree with me. These are the better candidates, yes? I'm getting higher, 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 but I will not achieve that one. So there is no maximum. So you see, it was not continuous, but still I had the maximum. But if this is not continuous, I might lose one of them. So two features are really important to guarantee you that there is a maximum and a minimum. Continuity of the function and closeness of the interval. If I give you a function which is continuous and I give you an interval which is closed, don't doubt about it. There exists minimum and maximum for that function. But if you relax that condition, it might still be true, but there is no guarantee. If you relax the continuity condition, it might still be true, but there is no guarantee to having maximum minimum. I want you to understand these features. Of course, this is a little bit higher level. What you concern is the function and this one. Yes, I think I will stop here because it would be, next time I will start with this lesson with a little bit harder example and some points so that when you are more energetic there, okay? So this is the lesson for today. We learned, I give you a continuous function, I give you a closed interval, and I ask you for the max and min, and then you learn the recipe, yes? So you need to follow, it's a step-by-step to find the maximum and minimum. But I don't consider this lesson to be completed yet, even though in the book it's just one page, but I think it's important. I will start at this half of the next session by continuing this, and then we move on, yes? Thank you very much. Thank you.